Alright folks, one last video here to work through the analysis of this 2x4 ANOVA that we just went through and finished the video on the screening. So again, our conservatism analyses here, hypothetical data, and what we're interested in is the unique and interactive effects of gender and religious affiliation on this scores on this measure of conservatism. And so what we're going to have in this 2x4, gender, our first factor, participant sex, male, female, our second factor having 4 levels, those individuals who report being unaffiliated with a given religion, people who identify as Catholic, people who identify as Protestant, people who identify as Jewish. And so what we're going to be looking at is the main effects of both of these factors as well as the interaction. And for this example, we're going to assume that we have absolutely no a priori hypotheses on how these data are going to turn out. And so what we're going to do is we're going to run through an example looking at a Benjamini-Hochberg approach to going through and trying to tease apart what types of effects that we get. Okay, so we've gone through, ran our screening. Looks like everything's pretty much good to go in terms of our assumptions, with the possible exception of wanting to be aware of the fact that we do have different cell sizes in this, but everything else looks pretty good. So we've spent all our time on our screening. It was like 20 minutes. We can jump right into the analyses. So for our 2x4 ANOVA, we're going to hit Analyze, go to General Linear Model, Univariate. Okay, so conservatism will be our dependent variable here. Gender, religious affiliation will be fixed factors, and then the only thing we're going to go through is we're going to hit options. We'll ask for descriptive statistics. We're going to ask for estimates of effect size and homogeneity tests here. Okay, so you're going to hit OK. I think that does it, and so I'm going to hit paste. In our syntax file here, and what I'm going to do is just make some notes. We'll say omnibus 2x4. Okay, just try and keep us help us keep track of what's going on. So we're going to run this and take a look at output. Okay, so we're starting out with our breakdown. So these would be our sample sizes corresponding to main effective gender and main effective religious affiliation. Remember, this is looking at differences in gender irrespective of religious affiliations. Here, religious affiliation irrespective of gender. Okay, going down through taking a look at our descriptive statistics. If we look for our males of different religious affiliation, women of different religious affiliation, again, it looks like people are scoring fairly similar across all of these. Okay, looking at our standard deviations, they're pretty similar. Again, in the screening, we had gone through and taken a look at our variances, and they looked okay. Noticing our cell sizes are different, but this is where we're going to get our cell means if we were to have an interaction effect here. Okay, going down through, taking a look. Our Levine's test is fails to reach statistical significance. Again, we had talked about that and noted that in the screening video previously. So we're not worried about huge differences in homogeneity of variance. And so what we're going to go down through is we're going to start look at our actual table here. So if we go through, remember we can ignore corrected model. We're ignoring intercept. Intercept is just saying that on average our mean value is something different than 0, which isn't terribly interesting. Here, though, what we're going to look at is our main effects of gender, right? So the question here is asking, are there differences in conservatism across men and women collapsing across religion? And if we go through, we take a look at our p-value here, we see that this is clearly not meeting criteria for statistical significance. Our partial eta squared is well below what would be considered anything that would be a small effect, and so we can rule out that main effect of gender. Here it looks like we have a marginal effect of religion, and a partial eta squared that's looks like it's within that small range. But then if we go down through and we take a look at our interaction effect, here we do have a statistically significant effect. If we're setting alpha level at 0.05, have our partial eta squared here, suggesting for that these data, this interaction effect is accounting for about 2% of the variability in conservatism, controlling for, after we partial out main effects of religion and gender. What we'd probably do if we were doing this for an actual set, go through, want to calculate a partial omega squared here too, to try and get a little better beat on the population effect. But what it does look like here, no main effects, but we do have a reliable interaction effect here. Okay, and remember, anytime we get an interaction effect, what this is telling us is that in this case, we're saying that differences in conservatism across religions or across religious affiliation is going to be dependent on respondent sex. Or we could flip that around. We could say differences in conservatism across respondent sex is dependent on religious affiliation. These interactions are symmetrical. You could go it either way. Hopefully, if this was a real life study, we would have some idea of how we would want to frame that. But we'll go through, and again, we're assuming for this demonstration that we have no a priori idea on what's going to turn out, and so this is all exploratory. We have an interaction effect in this 2x4 design, and so now what we need to do is we need to go through and start teasing apart and seeing what's going on with this interaction. So anytime you get an interaction, the first thing we need to do is go through and plot that out. Okay, so if we go through and we pull our means from our table here, and I'll pull this up because I've already done this, so you're not watching me enter means. But what we've done here, we have a small table. So for our male participants, our female participants, those who are unaffiliated, who identified as Catholic, Protestant, Jewish, right? So these are just pulling out of our descriptives here. So what we're going to do, highlight this, insert a table. Here, select that because I like that one better. All right, so here is our chart. This is, if we plot these means out, what we've got going on. And so it looks like we've got some pretty intense differences going on in this interaction. But what we always want to do, if you go through and take a look at our scale here, our scale is really short. Remember, our range for scores in this set was between 5 and 10. Range of the scale is from 1 to 10. And so this small scale is looking like it's magnifying effect. So what I'm going to do is I'm going to right click, say hit format chart area, format axis, there we go. I'm going to set this at 1 and that at 10 to give us a scaling on the real total value of scores on this measure. And so once we do that, now we start to see things a little bit differently. It looks like our men are all really close together. Okay, looks like our unaffiliated women have relatively low scores relative to our women who are reporting some religious affiliation. But what we need to do is go through and figure out how many exact tests that we have. Now, in this 2x4 design, we've got a total of 8 different cells. And if we were going to compare all possible pairwise comparisons, that would be 8 times 7 is 56. Half of that, 56 divided by 2, 28. So there's 28 possible pairwise comparisons that could be made in this set of 8 means. But remember that with our factorial design, we're not interested in all possible comparisons, because not all possible comparisons are interpretable. We can't make sense of that. Okay, so we can test among males. We can examine different religious affiliations within males, among women, right? And for within religious affiliation, we can compare unaffiliated men, unaffiliated women. What do we got? Catholic men, Catholic women. But it wouldn't make sense within these means to say compare unaffiliated men with Catholic women. We've crossed factors there, and so while the statistics police won't show up at our door and arrest us if we do this, we'll have just made a comparison that doesn't make any sense. Okay, so how many comparisons do we have in this 2x4 design? Well, we've got within each religion, male and female. So we've got 1, 2, 3, 4. Okay, so we've got 4 gender comparisons within religious affiliation, and then we also have within gender. We can make all of these pairwise comparisons across religious affiliation within gender. So here we've got 1, 2, 3, 4, 5. So we've got, is that, no, 1, 2, 3, 4, 5. All right. I'm missing one. 1, 2, 3, 4, 5, 6. There we go. Okay, so we've got 6 within this. We've got 6 within this. Also, we could take 4 times 3. So we've got 4 means here. Multiply it by number of means minus 1, which is 3. Divide that by 2 gives us 6, right? So we've got 6 comparisons here. We've got 6 comparisons here for 12. And then across, within religious affiliation, across gender, we've got initial 4 more. 1, 2, 3, 4. So 16 total comparisons, reasonable comparisons that we could make within in trying to pull apart this 2x4 interaction. That's a lot of comparisons, right? And so we don't want to just make those at per comparison error rates, because that's not going to be a reasonable approach. Our alpha inflation is going to go through the roof, right? We also wouldn't want to just run a post hoc analysis on this, because then that's going to have us accounting for all possible comparisons, and that's going to be way too much. And so what we want to do, and what we're going to do with this Benjamini-Hochberg example, is we're going to go through and set up our contrast across each one of these 16 tests using that procedure we had gone through talking about in class. Okay, now if I had some a priori hypotheses, I might try and slim this down. What I might do first is run a simple effects ANOVA. So I might, if I had a priori tests that I was going to go through and test, what I might do is go through and say split the file by gender, and then just run a one-way ANOVA across religious affiliation. And then what's going to happen is it's going to give me a one-way ANOVA across religious affiliation for men, across women. Probably what would happen is, as I wouldn't, in that simple effects ANOVA, I wouldn't find any effect of men, but I may find it for women. And so that would help cut down all of those within group contrast for men. But because this is completely post hoc, we've already gone through, we've looked at these means, decided that they probably weren't different. We still have to correct for that because we've already looked at them after the fact and decided they weren't different. We're still counting those as tests that we would run. Okay, so got 16 tests. We're looking at differences in men and women across religious affiliation, and then within religious affiliation, or within men and within women, we're looking at differences in religious affiliation there. So close this down for a moment and go back to our data. So what we want to do first is we'll go through and we'll go split file, and what we'll do is we'll split by religious affiliation. Okay, split by religious affiliation, and say OK. And so now anything we do in this set is going to break that test and look at that test specifically within each religious affiliation. And so what I'm going to do now is go analyze, compare means, independent sample t-test. I'm going to look at conservatism, and I'm going to look at differences in gender. Males are 1, females are 2. Hit continue, and then hit paste. Okay. So actually, here, let me go through and paste that in just so we can see. Split file, paste that there. Okay. So what's going to happen is we're going to split this file by religious affiliation, and so we'll say we're evaluating differences in gender across just so we can keep track of what we're doing here. Okay, so if we go through, highlight, and run this, what we're going to see is that for each religious group, what we're doing is we're running a comparison across men and women. So for our unaffiliated men and women, we can go through and take a look at Levine's test. We haven't violated here. Here's our test statistic. Looks like we have a marginal effect across men and women. For Catholic, again, we're not violating homogeneity of variance. Again, a marginal effect here across men and women for those identifying as Catholic. Protestant, no violation of homogeneity of variance. Once again, marginal effect there. And then we've got our individuals, our participants who are identifying as Jewish, no violations, and no evidence of a reliable difference there. Okay, so what we've done is we've gone through and we've tested here, 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 here. Okay, so we've got 4 of our 16 contrasts out of the way. Now what we're going to do is we're going to go down and we're going to resplit the file, but this time by gender. Okay, I'm going to hit paste here, right? And what we're going to do is we're going to look at differences within each one of these religious groups for men, and we're going to do the same thing over here for women. Okay, so what we're going to do is we're just going to run some pairwise tests. So I'm going to copy my t-tests here, right? And I know I'm going to have 6 of these. 1, 4. Okay, I'm going to compare, and if this, oops, religion, make sure I'm got the right independent variable here. 2, 3, 4, 5, 6. Okay, so we're going to go compare 1 versus 2. So this is unaffiliated versus Catholic. 1 versus 3, unaffiliated Protestant. 1 versus 4, unaffiliated Judaism. And then we're going to take a look at 2 versus 3. 2 versus 4. And 3 versus 4. Okay, and so what we're doing here is now we're evaluating differences in religious affiliation across gender. Okay, so again, what we're going to do now, again, to get among men, these contrasts here, among women, these tests here, we're going to run those with t-tests, splitting by gender, and then just running these in and of themselves. Okay, so we can go through, run this. If we've done this correctly here, go back up. this should be, okay, here we go. So here we've got looking at men, unaffiliated versus Catholic. Looks like we actually did violate our assumption of homogeneity of variance here, so we would go down, but our t-test is still nowhere near what we would call statistically reliable. Same comparison among women. Here we haven't violated, so we would look up here, and it looks like we do have a difference among 4 women. If we're comparing unaffiliated women with Catholic women, we are seeing differences in conservatism, where Catholic women are reporting significantly higher levels of conservatism than our unaffiliated women. If we're looking at comparison of unaffiliated men and Protestant men, no difference there. But for our unaffiliated women and our Protestant women, we are getting a reliable difference for that, right? And so we're going to go down through and look at the same things here. So unaffiliated and Jewish men, unaffiliated Jewish women. Here we've got, again, no difference in our men. Looks like we have a difference, at least at per comparison, alpha levels for women here. Catholicism versus Protestant, Catholic versus Jewish, and then Protestant Jewish men and women here. Okay, so we've got a lot of tests here. We've got a lot of stuff to try and sort out, and this can get confusing. But what we're going to do for the Benjamini-Hochberg, and I've already done this here, so we'll pull this up. So in the first set of tests, we looked at differences in men and women across affiliations. In the second set of tests, for men comparing religious affiliations, for women comparing religious affiliations. And so with the Benjamini-Hochberg, what I would do to try and manage these is I would go through and start taking our individual tests and start pasting them into some sort of table, right? And so if we go through and we see this is something I've already gone through, and just by double clicking here, we can go through and just copy paste, and you can go through and copy that into Excel if you wanted to. I've already done this because that would be tedious to watch me do it all. But what I've done is try and set up our comparisons here. So in this case, our religious affiliation is none. We're looking at men and women. Our t-statistic 1.898. Our p-value here is 0.062. Here we've got more specific. That's if you wanted to list that all the way out. So we've done that for unaffiliated men and women, Catholic men and women, Protestant men and women, Jewish men and women, right? And so we've got all these, and then gone through and posted down the same thing for men, non-Catholic, for women, non-Catholic, same thing here. So all I've done is just gone through and posted in the individual contrast test statistics and their p-values for all 16 valid comparisons that could be made. Okay, so now what we want to do, remember, with our Benjamini-Hochberg, if you go back through and take a look at that slide, what we want to do is we want to go through, I'm going to go through and insert this, and we're going to say, actually before we do that, delete. So what we want to do is I'm going to go through, just so we don't screw things up, and I'm going to view, freeze frames, okay, oops. I'll freeze this top row up here. Freeze top row, okay. So that way I've got everything set up. And so what we want to do with the Benjamini-Hochberg is we're going to go through and we want to sort this in descending order by our largest p-value going down to our smallest p-value. So what I'm going to do is I'm going to go here. I'm going to sort largest to smallest. Let's expand this. Okay, so we've got our test with our smallest test statistic, okay, all the way in terms of absolute value, ordered all the way up in order to our highest. Okay, and so what we're going to do with the Benjamini-Hochberg then is we're going to go through index number, and our index number will start with 16, 15, 14, all the way down. So our first test, oops, not that, that's not going to do what I want. Okay, so our first test, remember, is going to be our least difference here, our smallest test statistic, the closest difference in these two groups. And so what we're going to do is we're going to test this one at the least conservative criteria, and then with Benjamini-Hochberg, we're going to go down through and test at increasingly stringent levels. So recall, for Benjamini-Hochberg, what we're going to do is we're going to create a critical value by taking our index number here, dividing it by the total number of tests that we're running, and then multiplying that by our per comparison error rate, which is going to be 0.05. So what I'm going to say is I'm going to say this is going to be equal to my index number divided by 16, which is the total number of tests that I have, multiplied by 0.05, which is going to be my per comparison error rate. And I hit that, and I've got so our first test here is going to be evaluated at our per comparison error rate. I'm just going to take this. Okay. But then what I'm going to do, and this is easy to do in Excel, I'm going to take this and drag this down. Okay. And so what it's going to do, you can see up here in the field here, we're taking each one of these is just taking the index number. So for this, we've got 9 divided by 16, the total number, times 0.05, which gives us a criterion value for our eighth test, our eighth test here at 0.028, down and down and down. And so then what we do is we're going to go through and take a look and see if our p-value for our test statistic meets our critical value under the Benjamini-Hochberg. So we actually don't get into a statistically significant difference even at per comparison error rates until we get down to the contrast for women, the difference between unaffiliated women and Jewish women. At per comparison error rates, we would identify this as statistically reliable, but by the time we get down to our 14th test in the Benjamini-Hochberg, our critical value is 0.009, and so even though this is statistically reliable at per comparison error rates, we wouldn't calculate it, identify it as statistically significant with Benjamini-Hochberg. But our last two contrasts for our women, the comparison of unaffiliated women with Protestant women and unaffiliated women and Catholic women, both of these are associated with a p-value in the test that's less than our criterion under Benjamini-Hochberg, and so both of these would be the two post hoc tests that would be statistically reliable. Okay, and so again, what we've got here, difference between our Protestant women, our unaffiliated women or Protestant women, unaffiliated women, and Catholic women. If we go through and we were to calculate effect sizes with our handy-dandy effect size calculator using our means and standard deviations here, we would get hedges G here of 0.62. Hedges G here is going to be 0.83, okay? And if we were to calculate our an effect size here, this is actually pretty similar. Our effect size here is 0.59. So very similar in terms of overall effect, right? And what we might want to do in a follow-up test is suggest that, there might be differences between unaffiliated women and women who identify with Judaism. It's just we ran a bunch of post hoc tests because we didn't come in with any a priori hypotheses. And so even though this is statistically reliable at per comparison error rates, after our corrections for post hocs, this one isn't turning up as statistically significant. So what we do have out of all the comparisons that could be made here and reasonably interpreted, it looks like our only differences are going to be among our women and for our unaffiliated Protestant versus our unaffiliated Catholic. So if we go back over to our graph, some things that we would want to go through and conclude based on this overall analysis. Okay, we would say based on our omnibus test, we would, and given the presence of this interaction, right, we would say that differences in conservatism across different religious affiliations, those differences depend on whether or not we're talking about men or women. Okay, so the relation of religious affiliation with conservatism is dependent upon gender. That's what this interaction is telling us. If we go through and we actually run our post hoc tests, what we find is that we have no difference in conservatism across religious affiliation in men, right? So among men, doesn't matter if you're unaffiliated, Catholic, Protestant, Jewish, no differences in conservatism, at least in these data here among men. However, well, before we get there, also, no difference is among men and women within individual religious groups. So if we're talking about unaffiliated individuals, Catholic individuals, Protestant individuals, Jewish individuals, we're not seeing differences across gender differences in overall conservatism. However, if we're thinking about women, what we do find is that women who are don't affiliate with any religious institution, we find our unaffiliated women are reporting lower levels of conservatism than our Catholic women. Our unaffiliated women are also reporting lower levels of conservatism than our Protestant women. For the difference in our unaffiliated and Catholic groups, unaffiliated women are reporting on average about their average score, conservatism score among unaffiliated women is about 0.6 of a standard deviation below that of Catholic women, about 0.8 of a standard deviation below Catholic women, and our unaffiliated women are about 0.6 of a standard deviation below Protestant women. We looked like we got something that was close in terms of our comparison of our unaffiliated women and our Jewish women here at an effect size that was very similar to our Protestant women. It was just that we couldn't claim that as statistically reliable given the fact that we had such a large correction for all 16 post hoc comparisons that could be made in this 2x4 design. Okay, so overall conclusions, looks like for men, religious affiliation has no impact on conservatism, and within each religious affiliation, no gender differences there. But specifically, if we're looking at women, looks like our unaffiliated women are reporting less conservative beliefs than are our Catholic women and our Protestant women, and jury's still out on whether or not we would, in a replication, identify differences across our unaffiliated women and our women who are identifying with Judaism. So that's an example of how we might go through with the Benjamini-Hochberg. This is nice because this approach takes, as we talked about in class, a little bit different. If just to show you what would look like if we took a Bonferroni correction, 0.05 divided by 16, that's pretty intense. By the time we get to the 16th test, we're about where we would be with a Bonferroni, but we also have up here things that we wouldn't have caught with the overly conservative Bonferroni test with this. So hopefully this helps with how to use Benjamini-Hochberg in a factorial ANOVA design. If you have any questions, let me know. Happy to help you out with any snags on this last set. But good luck, and yeah, let me know if you have questions. Thanks.